Hello friends, today we'll be talking about the organic reactions of PCl3, PCl5 and SOCl2, phosphorus trichloride, phosphorus pentachloride and thionyl chloride. You know, this is one of the important most topic there in organic chemistry. Almost every year questions are coming from this and is a very large number of reactions. See, as I told you, organic reactions of PCl3, PCl5 and SOCl2. This is our today's topic. See, here what have you written? You have written PCl3. So PCl3 won't be only PCl3. It can be PBr3, it can be PI3, all are one and the same thing. All are one and the same thing. In what context? In terms of products. What have you taken? You have taken PCl3, PBr3 or PI3. Instead of taking these, you can take red phosphorus plus 3Cl2, or you can take red phosphorus plus 3Br2, or you can take red phosphorus plus 3I2. In all the three cases, you will be getting finally PCl3, PBr3 or PI3. So in that context, all are one and the same. Instead of taking red phosphorus plus 3Cl2, what else you can take? You can take red phosphorus plus HCl or red phosphorus plus HBr or red phosphorus plus HI. So see, such a big number of reactions from entire organic chemistry. Not only in organic chemistry, but you will be getting all these reactions there in inorganic chemistry also. 5th A group P block elements. So see here how I will be managing all these reactions. As I told you, it's a very big number of reactions. Whenever any organic compound reacts with PCl3, whenever any organic compound reacts with PCl3, PBr3 or PI3, product formed will always be H3PO3, other than this very important organic compound. That organic compound depends upon this reactant. What reactant you will be taking here, according to that, here you will be getting product. And in different cases, it varies. For doing reactions like this, you must be very good in valency. That's a very basic thing there in chemistry. And you must be very good in balancing too. That's also a basic thing therein. In 9th and 10th class itself, you should know all these things. 99.99% probability of asking question will be from this region, and that varies there in different organic compounds, and there I am 0, but still see how I will be managing this all. Organic is very easy, but you should know the right method. You should be good in nomenclature, you should be good in valency, that's all. This reaction will be there in the chemical properties of this organic compound. First time. Second time, in organic chemistry, this reaction will be there in the method of preparation of this compound. This reaction will be there in chemical properties of PCl3 in organic chemistry. This reaction will be there in the method of preparation of phosphorus acid in organic chemistry. So this is not one reaction. In chemistry, you will be getting this reaction there minimally 4 times. If it is PCl3, then 4 times. If it is PBr3, then 4 times. And if it is PI3, then 4 times. So this is not 1, it is 12. If you will be taking red phosphorus plus 3Cl2 or red phosphorus plus 3Br2 or red phosphorus plus 3I2, again 12. If it is red phosphorus plus HCl, HBr, Hi, again 12. So this is not one reaction. Minimally, with one compound, this will be 36 times. If it is alcohol, then 36. If it is ether, then 36. If it is aldehyde, then 36. If it is carboxylic acid, 36. Phenol, 36. So in entire organic chemistry, such reactions will be there in hundreds of times, again and again, everywhere. Once again, instead of taking now PCl3, I will be taking the next one, PCl5. Whenever any organic compound reacts with PCl5, product formed will always be POCl3, that is phosphoryl chloride. Whenever an organic compound reacts with PCl5, product formed will always be this compound plus POCl3, that is phosphoryl chloride. I will be taking different examples there. We will come to know about all such compounds and how you will be managing that also. Whether this reaction will be possible or not, that also we will be discussing. Whenever any organic compound reacts with SOCl2, thionyl chloride, in presence of pyridine C5H5N, product formed will always be SO2. Product formed will always be SO2. You know, this reaction is also known as Darzon's reaction, and is the amongst all the three, this reaction will be the best one, because to get haloalkane, because the main product will be haloalkane and the byproducts will be there in the gaseous form. So here haloalkane you will be getting in most purest form amongst all the three. So this is what the point is for today's class. Whenever PCl3 reacts with any organic compound, product formed will always be H3PO3 if that reaction is possible then. If any organic compound reacts with PCl5, product formed will always be POCl3, that is phosphoryl chloride. And if any organic compound reacts with SOCl2 in presence of C5H5N, heterocyclic pyridine, then product formed will always be SO2. Now we will be taking one by one all the three reactions. As we have already discussed there in some other video about the organic reactions of PCl3, there I have taken so many examples related to this PCl3, so I won't be talking about that all such reactions here in this video. Now we are talking all these reactions in terms of normal conditions. If some exceptional conditions are there, then obviously products will be different from all these things what we have written. Here I will be taking one reaction of phenol with PCl3. Already, as I have told you, PCl3, I will be taking one reaction C6H5OH plus PCl3. As I have already told you, whenever reactant is PCl3 in any organic reaction, product formed will always be H3PO3. From where this H and O comes, in this H3PO3, from where this H and O comes, this H and O will always be there from the functional group. See, in ether, functional group is O. In that functional group, H is not there. So H3PO3, how can be formed? No, na. Ketone, functional group is CO. There is no H. So how H3PO3 can be formed? So all those compounds in which their functional group H or O or both of them are not there, then all such compounds will never be reacting with PCl3 to form H3PO3. So you need not to bother about such reactions. H and O must always be there from the functional group in this H3PO3. So see what here functional group is. Here functional group is H and O. So in this functional group H and O are there. So this can give this reaction to form H3PO3. That we will check. See here how many H and O you have written. You have written 3H and 3O. But here in this functional group, how many H and O are there? 1H and 1O are there. And what your requirement is 3H and 3O. So what you should do? You should multiply this by 3. Now see this H3 and this P. H3PO3 to form H3PO3. Now see what rest is. Rest is 3C6H5. 3C6H5 and here what it is there? 3Cl. So now it is balanced now. So here valency as well as balancing, both issues are addressed. So this reaction is possible. If phenol is in excess, this is the normal concentration of phenol. But if phenol is in excess, then the product formed will be triphenyl phosphate. Triphenyl phosphate. So that is exceptional one. So in some other video we will talk about that too. So this is about PCl3, which we have already addressed there in my previous videos. So just go through. Now see, I'll be talking about the second one. That is with PCl5. Organic compound when reacts with PCl5, product formed will always be POCl3, that is phosphoryl chloride. C, I'll be taking C2H5OH plus PCl5. What I have told you, everybody gives importance to this, but don't give importance to this. That will be simply mugging up. So instead of mugging it up, just to do using my method, what will be the product? POCl3. This you should remember. That is much easier now. PCl5, POCl3, PCl3, H3PO3, SOCl2, SO2. That's all. Everywhere that is same. So you need not to work so hard. Now see from where this POCl3 will be coming. See, this is 1P, this is O, and 3Cl you have taken from here. This 1P, 1O, and 3Cl you have taken from here. So in this way POCl3 will be formed. Now what rest is? Rest is 1C2H5, 1H and 2Cl. 1Cl will combine with 1C2H5 and 1Cl will combine with H to form C2H5Cl plus HCl. C2H5Cl plus HCl. Other than this POCl3. Now see here valency as well as balancing both are addressed. What does it mean? It means this reaction is possible. If valency or balancing any one is not addressed correctly, then obviously this reaction won't be possible. This is the best way to come to know whether this reaction will be possible or not. Now see, instead of taking this C2H5OH, now I will be taking C2H5O, C2H5 plus PCl5. See what I have told you, product formed will always be POCl3. See how this POCl3 will be taking this is P, this is O, and 3Cl will be taken from here. Now see what rest is. 1C2H5, 1C2H5, 2C2H5, and here 2Cl. So twice C2H5, Cl. That's all. Here also valency as well as balancing both are addressed. See, in all these videos I will be taking only those reactions which are covering very big portion from their organic chemistry, and from there our probability of asking question is little more. So we'll be trying to help you there in all such topics first. Now see, this alcohol is over. Now this ether is over. Now I will be going to the second one, that is aldehyde. CH3 CHO plus PCl5. Again here, what will be your main product? POCl3. See, the same thing. See how calmly, how patiently I am doing this all. Always, otherwise organic is the difficult most portion there for especially JEE writing students. P, you will be taking from here O and 3Cl. 3Cl. What rest is? Rest is CH3CH and Cl2. C, CH3, CH, 2Cl are also there. So CH3, CHCl2. See what this is. This is ethylidene chloride. This is jamenyl dichloride. This is 1,1-dichloroethane. How you will come to know whether it is ethylidene chloride or ethylene dichloride? Jamenyl is always lidene. Jamenyl is always lidene. If both halogens are there, they are on the same carbon atom, that is jamenyl na, gem means same. So will always be alkylidene chloride, ethylidene chloride, propylidene chloride, butylidene chloride, alkylidene chloride. So this is jamenyl dichloride, this is ethylidene chloride, or this is 1,1-dichloroethane. Now see, I will be taking organic acid now, carboxylic acid now, CH3COOH plus PCl5. Product, as I already told you, POCl3. See how easy it is. Everywhere POCl3, 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 POCl3. So remembering this is much more easier than remembering all these different compounds now. All those different compounds I can manage with the help of valency and balancing. So won't be going to an issue for me to manage. And 99.99% they will be asking questions from here only. What I was trying to tell you there in the beginning, see, one time you will get this reaction there in chemical properties of ether, method of preparation of haloalkane, chemical properties of PCl5, and method of preparation of POCl3. So this is not one, it is at least four. It is at least four. 4 times minimally you will be getting all such reactions. Now see,